Nice shot. Hey folks, Rich here at rcinformer.com. Thanks for checking out this video on the Super Cessna by Shulman Aviation. This plane has quite a bit of history. It was designed back in the 70s by Ron Parchment, primarily as a glow airplane, and Shulman Aviation has modernized it to be primarily an electric airplane, while still including a motor mount for glow for people who still like to use a glow motor in it. It really is a go anywhere, do anything airplane, and it's the kind of airplane that, regardless of weather conditions, regardless of what your mission for the day is, it's the one airplane that you can take with you and accomplish anything you want to. For example, you have a friend maybe that wants to learn how to fly. You can take this plane out there, hook it up on a buddy box, and you can give somebody flight instruction. It has tough landing gear so they can learn takeoffs and landings. And when you're done with that, you can do advanced maneuvers with it. Knife edges, it does fantastic spins, stall turns, loops, rolls, point rolls, you name it. Anything you want to do, this airplane will do. And the nice thing is it's a nice departure from a lot of the foam airplanes, because it really kind of combines the 70s era almost with today, because it's a nice tough, nice rugged wood airframe, but it uses a modern electric power plant, and the two together are just a tremendous combination. Now, this is not your ordinary Cessna. It's specifically designed to handle multiple roles, as I just discussed, training to advanced flying. It's designed specifically with a symmetrical wing that gives you tons of performance and no dihedral for that typical roll stability, but the plane still maintains tremendous roll stability. So its aerobatic ability comes from having that symmetrical wing, having no dihedral in the wing and a nice flat fuselage side for doing knife edge type maneuvers. The landing gear is super tough, so whether you're learning to fly or you make a bad landing, this thing will take just about anything. In addition to that, it's nice and small. It's not a tiny airplane, but it's not a huge airplane. Typically, it's pretty much like your 40 size trainer used to be. But you can unbolt the wings with 2 screws here, and it'll fit in the back of most cars without having to flip seats down or do any of that kind of thing with it. Performance can be whatever you want it to be. We've been flying it. The entire video you saw was flown on 4 cells, and it has plenty of power, but power options are pretty much just about unlimited with this thing. So you know, if you want to go 5, 6 cells even, look out, because it probably will have a tremendous amount of power with that, and there's a tremendous battery compartment in there to handle almost anything that you want. The quality of this thing pretty much is top notch. It's all laser cut, and one thing that I noticed about it that really stands out on it is really all the detailing work that they did, the monocoat or the ultra coat or the whatever coating they used on this thing. But it's so nicely applied, and the quality of the building at the factory, this stuff is so nicely applied on there, it's almost as if it's painted. And usually when there's stripes and so forth, details put on the airplane, a lot of times these covering materials will come off. But again, it's done so well, it's laser cut, and it's almost as if it was painted onto the surface of the plane. Again, quality second to none. They did an excellent job at the factory building this thing. The building of the airplane is relatively simple. It's a simple spar, gluing the wing together. You glue your elevator and your tail on. You do have to hinge everything, and then you're pretty much done after mounting your motor. Anyway, guys, I went ahead and put together the following video. The video is going to show you, give you a review, show you all the parts of the airplane, some of my thoughts on everything, and then it's going to go into a detailed guide for hints and tips and things like that. The instructions that came with the airplane are pretty high quality. They're not in color, but it will show you really how to put this thing together. It's a very easy build. But again, the following video is going to guide you through and give you some good tips, some good hints, some good suggestions for getting this thing together that will actually make the plane even safer than it is, stronger than it is, and just make it overall perform a little bit better. Anyway, guys, without further delay, let's get on with the video. To start off the review of the Super Cessna, you can see the inside box the airplane came in. The outer crate was already removed. On the front of the box, we have a nice colorful label showing some of the dimensions and the 2 color options that are available for the airplane. Let's go ahead and get the parts out of the box, and we'll see what comes inside. With the box top removed, you can see everything comes neatly packaged inside the airplane. Everything's taped in and secure, individually wrapped, so everything's in real good shape with instructions. If you get the optional package for the airplane with the motor and speed controller and servos, everything comes sort of in a separate bag. And you can see in there, you get a cowling in there, everything's all taped in there. Let's go ahead and get the parts out, spread them out, and we'll inspect everything. Here's a layout of all the parts that came in the box of the basic kit. Everything is in very nice shape. Everything was individually bagged and taped securely, so things didn't fly around inside the cardboard box and get damaged. Everything looks like it's in good shape. There is a little bit of wrinkling in the material, but that's pretty normal for any covering material that's packaged in boxes. I'll just take an iron and a heat gun and just kind of take those out of there, those wrinkles out. But you have your fuselage and the fiberglass cowl here at the top. It's real nice quality. 2 wing panels, elevator, and rudder. You can see the wing spar right here that glues the 2 wings together. All the hinge slots are already cut in this thing. You just need to install the hinges, which actually come in one of these separate bags. So you can see all the surfaces are taped nicely in place, including the rudder, elevator, ailerons. Down at the bottom we have some linkages. You can see the elevator rod for you with a carbon rod is actually already assembled and made up for you. There's a servo box right here for the Aileron Servo. Of course, you get 3 wheels, the landing gear, different parts bags with nuts, bolts, screws, And of course you have the option to make this plane electric with this electric motor mount right here, or the gas mount. So they include both, and the nice thing is it appears as though you can actually change from one to the other. If you install one and you don't like it, if you don't like the electric or you don't like the gas, you can convert it to the other one without permanently putting anything in place. So anyway, there's the layout of all the parts, and everything looks like it's really in nice shape. Last but not least, included with the basic kit are a couple of tail numbers that you can stick on the side of the airplane, and some Shulman Aviation and Super Cessna stickers and Fury motor stickers that you can apply to your airplane wherever you like. And the set of instructions. Real impressed with this instruction manual. It's not in color, but it's probably one of the best written and most thorough manuals that I think I've seen in a while. Again, not in color, but lots of detail in here. So, especially if you're somebody that's never built a wood airplane before, this goes into a lot of information that you may not know if you've never built a wood airplane before. So, putting CA in the screw holes and things like that. So, lots and lots of good detail for anybody to build this airplane. Lots of schematics and diagrams and so forth. Here, for example, they show you the mounting of the electric motor and the gas motor, how you do it and what they look like. Here's an actual size cutout that you can line up this dotted line with the end of the cowling. And if you're going to use a glow motor, you can go ahead and you can cut out the pattern in the cowling for the diagonally mounted motor, just like they show here. And on the last page, fuel tank diagram showing you how to put that in. It also shows you control throws for different radios, gives you rate information as well, and center of gravity. So very thorough, real nicely done manual, very simple, but lots and lots of information in here. One of the nice things about this plane is that you have a lot of power options. You can go with numerous glow options and numerous electric options. And really the sky's the limit on that. I went ahead and got the Fury package though that they were selling with the airplane, and it's a Fury 4150 570 kV outrunner that looks like it's super nice quality, and I've seen one video on it where it's just a real hot rod setup. Speed controller is a 55 amp Fury controller with BEC. It also comes with 3003 Futaba standard servos. So we'll get this all bolted on, we'll get it out the field, and we'll see how it all performs. After opening up the motor box, I thought I would show you what's inside here. It comes packaged in this really nice foam brick that keeps everything real well protected, and it comes with all the accessories in here, which is pretty complete. Now, you're not going to use all this stuff, but it comes with this really nice collet drive that I'm probably not going to be using on the airplane because of the way the motor mounts, but definitely this is a real high-end, real nice one that you can definitely use on another project. This is the one that I'm going to be using on the airplane, and this is going to secure to the front of the motor with the 4 screws that they provide. The X mount is what's going to mount this thing to the bulkhead, which you'll see further down the line here in the assembly process, and all this stuff fits nicely. They give you a little spacer that you're not really going to use for anything, but again, on a future mount you may find it necessary to use somewhere. Here's all your hardware. They also include all the screws you need, but they also include a wheel collar that you're going to want to put here on the back of the motor. And here's the motor itself, and there's the retaining ring that holds the shaft in, and you're going to want to slide that wheel collar on the back side, tighten it up, probably even file a tiny flat spot in there for the set screw to help keep it in place. But real impressed with the motor quality, guys. It's definitely a higher end motor than some of the ones that I'm actually used to using. And you can see here it's a 4150 570 kV Fury brushless motor. But definitely, guys, real top-notch motor, real nice package that they give you for this airplane. Before I go into too much detail on the building and some tips and tricks and suggestions for this airplane, I thought I'd cover some of the parts. Starting off with the fuselage here, very nice, super nice quality, guys. This is all balsa side panels backed up with a light ply subframe, and everything's laser cut and real nice and precise. Again, as you go around here and you see some of these wrinkles, no big deal. An ultracoat or a monocoat iron A heat iron, a heat gun will take all these wrinkles right out. It's just, that's common for wood airplanes when they're packaged. You can see already all the pre laser cut holes for your nose strut, your motor and everything. You're going to drill a few holes in here to mount the electric motor block in there. That's a pretty simple procedure. It comes with blind nuts and everything to do all that. But overall, it looks real precise. Just taking actually a smell of this thing, I can tell that they used a lot of white glue in here. And white glue is real good on wood as long as they do use enough. So you do want to check each of these parts and make sure that, like, your battery tray, your servo tray, is not loose in there, and it's not. They actually did a real good job gluing this whole thing together. You see your throttle rod if you're running a glow motor, and your nose wheel steering guide tubes, I should say, are already installed there for you. So if you come up with any of these that are loose, just put a drop of CA on those and in the joints where they may be loose, and that'll tighten everything right up. You can see your forward pin for your wing, and you can see the two main wing screws with blind nuts that are already installed in the back. And they give you a couple of spots right there and right there to go ahead and put a switch through the side. The gear mounting is right underneath here, and you just cut through the ultra coat as per the instructions, and you mount those with some gear straps. Moving on to the back, to the tail, nothing out of the ordinary here. Another slot you're going to cut after you you know, heat up the ultra coat and get this all nice and flat. You'll cut this out and the elevator will fit in there, and you can see the elevator rod comes all the way through out the top and attaches to the top of the elevator. So, you know, if you drag your tail on the landing, you're not going to snag an elevator horn, which is real nice. But overall, guys, fuselage, real nice quality, A+, excellent condition. Here we have one of the wing panels. The first thing off the bat I notice is that it's super light, very lightweight, and very solid construction. It definitely has a real rigid feel to it. Again, a few wrinkles, but heat gun and iron will take all that out. Ailerons are already, everything's sort of pre-installed except for the hinges. They are taped on, so you have to remove the tape, put your hinges in there and CA them in place, and the instructions go through that pretty thoroughly. As far as the ailerons, elevator, and rudder go, I did put out a video on installing CA hinges, and it's a way that I like to do them. Please check out that video if you want to know an alternate way, what I think is a really good way to install CA hinges, so check that out. There's also a video I put out on how to install wings, and the instruction manual for this airplane actually covers it very well. So, but check out those two videos if you want a little bit of guidance if you haven't done it before. Those videos on RC Informer will help you out with those. This is the wing spar included, and it just fits traditionally right into that spar block, and it's a nice tight fit, so this thing will go together really well. Again, the push rod or the torque rod for the aileron is already hooked up. Here's an anti-rotation pin already glued in to put this together, and you can see the slot cut where you're going to put the box for the Aileron Servo. Nice ultra coat detail. I think they laser cut these out or cut them out with a hot gun or something and then put them on, but they almost appear to be painted on there. But the detailing of these stripes is really quite nice. Anyway, excellent quality and a nice differentiation of colors of the wings. You notice the top has this sort of red sweeping design, and the underside has just straight stripes. So it really helps you kind of see the underside of the airplane when you're flying it. Real nice quality wing. Here's a quick look at the vertical and horizontal stabilizer and the elevator and rudder. They do need to be hinged. The hinges are included, so just a little bit of CA, follow the instructions, you know, get them in there real nicely. Quality looks real good. They're both built up. You can see they're very actually lightweight, but real rigid. So real nice quality, guys. Real good job they did on the factory, on the assembly line, putting these together. Also included with the kit is this fiberglass cowl. Real nice painted. Looks like it has maybe even a clear coat over it, but I don't see any cooling in it, so we're probably going to put a couple of holes. I'll talk about that a little later on in the video, but probably a couple holes up here and maybe one in the bottom here to let the air out. But nicely painted, nice fiberglass, nice solid cowl. The last thing I want to cover is these two laser cut wood parts they give you. This one here is the motor mount, and this one is the wing mount for the wing for the Aileron servos. A lot of times when they glue these together on the assembly line, sometimes they don't put enough glue on them. This one has a tongue and groove design, so there's really no problem with this, and as I'm looking at both of them, they are pretty solid. But if you have any question marks about maybe they put enough glue or didn't put enough glue, you can always just inspect it and make sure they did, and if not, you know, take some thin or medium CA even and just run it along the edges on the inside, run it along here, and let the glue just sort of wick in there and make the mount more solid. I'm particularly probably going to do that with this Aileron Servo because it looks like maybe these blocks might be a little loose, and the last thing you want to do is lose the Aileron Servo. Here you can see right there it's actually flexing a little bit. So and that's where the servo is going to mount. Not a big deal. Just take some thin CA, put it in here, let it wick in there all along these edges to make sure that those don't come out. And if you need to, you know, put some medium CA on the inside and just sort of make a fillet, hit it with some kicker, and that'll make these parts much tougher. Anyway, guys, that's pretty much it for the parts on this airplane. Everything is real nice quality and real nice shape. Now we're going to go ahead and get on with the building, and I'm going to show you guys some tips, tricks, upgrades, and suggestions for getting this model in the air. The first step to the assembly process is getting the wing together, and I wanted to show you my completed wing. You can see you get all the wrinkles out with a heat gun, and it looks tight as a drum. You can see it's nice and clean after you get the heat gun on there. The first thing is joining the wings together, but I suggest before doing that that you go ahead and hinge your ailerons first, and that just makes it a lot easier. When you glue the thing together, the two halves together, and then you try and put your ailerons in, it's just tough working with a large wing. So you get your ailerons on first, then glue your two halves together. Very simple getting the two halves together. The wing is simple and small enough, and it fit real nice that using 30-minute epoxy, I was able to actually glue the servo box in place with the wings at the same time, and then just run some tape across. So, you know, if you follow the instructions and just do how they say, this wing goes together really quick. The very next step after assembling the wing, after you let it dry, is to go ahead and attach it to the airplane. Go ahead and secure it the way it's going to be during flight. The reason for that is that the very next step of assembly is putting the horizontal stabilizer on. And you can see from this picture how parallel I was able to get the elevator or the horizontal stabilizer to the wing. You can see that you have an equal distance right here between here and the wing, and an equal distance between here and the wing. You also want to measure from this corner, okay, to the corner of the wing, and from this corner to the corner of the wing, and make sure that all the measurements are equal. If you clamp the center of this together right here, okay, just let it dry, there's a chance that you may actually make this entire elevator not parallel to the wing. So you don't want to have this clamped when you glue it. You just want to apply you want to test fit it, apply the glue, and then put it in a comfortable position and put the pins underneath that you can see, just like the instructions say. And you want to make sure you get it parallel like you see in this picture, and then go ahead and let it dry. Now that the horizontal stabilizer is thoroughly glued in position, you want to make sure you give it plenty of time to dry, make sure it's in place. You can sort of eyeball it from here and see, again, it's nice and parallel to the wing, which is just the way we want it. The next step is to get the vertical stabilizer glued in position just as true, but at a 90-degree angle, of course. You follow the instructions just the way they say. They do a really good job in showing you how to run tape from the top all the way down to each tip of the horizontal stabilizer and get everything to dry in position. You also want to use a 90-degree tool such as the square, and just by holding it here, you can line it up, and you want to measure several times with it taped all in position and make little adjustments if you need to. But once you're sure that it's at a 90-degree angle and it's pointing vertical, everything's nice and true and taped, you can just leave it alone and let it dry. You'll end up with what we have here, which is a really nice true vertical stabilizer. You'll notice here the difference in gluing this with the wings is that I left the rudder and the elevator off. It's just much easier dealing with these surfaces and getting them true without having those things flapping around. I did pre-fit them and test fit them beforehand, so they're actually ready to be CA'd on position now. And once the horizontal and the vertical stabilizer are glued in position just the way you see it here, now you can go ahead and use your CA hinges and get those surfaces glued on. A couple items to note when mounting the motor onto the motor block and then the motor block here onto the airplane. You notice back here I used blind nuts, but I also had to make my own square little piece of light ply or regular ply, whatever you want to use. I use light ply back there. The reason for that is if you just put the blind nut through, you can see that this bulkhead running through here, this whole bulkhead here, is not really that thick, and it doesn't need to be, but if you just put the blind nut in without an extra block back there, the blind nut will pull far enough through that the metal thread ends will actually poke through here, and then your motor won't seat properly, and it probably would wobble a little bit. So you need to actually make this whole thing a little thicker by adding that little piece of light ply, so the blind nut can countersink into it without sticking through this front half. The other thing I noticed too, it's kind of a small thing, but you do the same thing really on the fuselage end. You can see the large holes here. These are meant for mounting a glow motor, but these other holes here are meant for actually mounting this. So you're going to go ahead and put blind nuts back behind this bulkhead, just like you did with these front ones. The only difference here is, now I guess you could use self-tapping screws if you wanted to, but I'm going to use blind nuts. The difference is you need to actually take a drill and drill a hole here, 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 and here, and then you can mount your blind nut through the back side, and then you can go ahead and put a screw right through there and tighten it in place. The good news here is the bulkhead is thick. It's a double ply here because it's obviously meant to be a firewall for a glow motor if you choose to go that route. So it's thick enough that you can just put the blind nut through without having to add a block on the other side. Here's a look at my completed wing panel after it's all together and assembled, and I have a couple of suggestions and some upgrades here for you. The first is merely just, you know, in addition to using blue Loctite on your threads of your wing screws to keep them from backing out, you can also use a piece of fuel tubing like I have here, or an O-ring. That helps you keep the screws from losing the screws, and it also helps keep the screws from backing out. And you can screw these in, and you can feel the bite of the rubber fuel tubing as you tighten the thing in, so it'll help keep your wing screws in there. The second thing that I did is right behind it, which is the epoxy bearing that I made. It's real simple to do, and the reason that I did it was because I found that there was kind of a little bit of play in here, as I do with a lot of these other wood models using torque rods. You can see here as I move this aileron on this side, watch what happens. The center, okay, right here, the one with the torque rod, or with the one with the bearing in it, the epoxy bearing, hardly moves at all. But if I move this aileron, watch what happens to this one. See how much it moves? You can even hear it. Let's go ahead and zoom in on that, and I'll show you a much closer shot of that. Again, I'll move the right side here, and you can see it hardly moves at all. Almost no play. I move this side, see all that play in there? And that kind of just makes the control sloppy. Now this isn't something you have to do. This is just something I like to do to tighten up my controls and give it a little bit more solid feel. Not every airplane comes from the factory like this, and a lot of all manufacturers sometimes have a little bit too much play in there. You can fly the plane just the way it is and won't have any problem, but if you want to tighten them up, I'm going to go ahead and in the next following clips here, I'm going to show you how you can tighten those things up and put a simple epoxy bearing in there, and it'll help tighten up and get rid of the play in your control surfaces. The first step to making the epoxy bearing is to just take a hobby knife and cut right along here like I already did. And you just have to cut down just a little ways, and there's just an empty channel in there with the torque rod. You go ahead and you cut here, here, and along these two lines. And once the cuts are made, just like you see them, you can just take your hobby knife and just pop these pieces out. And what it's going to do is it's going to expose the torque rod in there, and you can see it in there. And again, you could go ahead and move this thing, and you can see all the play that's in this thing side to side as I move this thing. And what we're going to do is we're going to end up filling that with epoxy. Now this little extra channel right here I cut, which you'll see in the next step, is for putting a protector over this thing for lubricating the torque rod. With the exposed torque rod here, all you got to do is just take a little piece of, this is actually the back of a sticker sheet. You could use aluminum foil, wax paper, whatever you can stick back there. And what you're going to do is you're going to very carefully, by bending this thing, you're going to go ahead and shove it underneath as best you can this torque rod. You might need to sort of pull up on it a little bit, and get it and very carefully just slide it in there without tearing it. The reason that we're putting this thing in here is that what we're going to do is we're going to lubricate this thing, and the deal is that anything that oil gets on, for the most part, epoxy will not stick to it, and we don't want epoxy to stick to the torque rod. Now the torque rod is metal, epoxy doesn't stick to it anyway, but we want something on the torque rod, the metal torque rod, that'll act as a releasing agent. Now you can use just oil, which I'm going to use here. You can use chapstick if you have an exposed torque rod that you can get chapstick around, or WD-40, or really any lubricant, because again, epoxy is not going to stick to it. The next thing we're going to do is just take the oil, and very carefully, we want to try not to get it on the wood, but if we get some on there, it's not going to affect the thing. But you're going to go ahead and you're going to put it on the torque rod, okay? And we're going to let it kind of seep down in there. We don't want to leave this in there too long. But again, we do want to use some sort of a material here that's not just going to soak through and go down into the wood, because we want to try and keep it off the wood as much as possible. Once we have the oil on there, we're going to sort of pull both sides of this thing and make sure we fully lubricate the torque rod. So the oil is going to get underneath, and it's going to get all over this thing. And once we're pretty sure that the whole thing is lubricated, which it looks like it is, I'm going to put a little bit more oil on here. I think I missed a spot there. Once the oil is on there, we're going to go ahead and just remove this thing, and you can simply just pull this thing out. Okay, now the torque rod is completely lubricated, and we're ready to move on to the next step. Now this next step is the farthest thing from rocket science. All you really need to do is just make a couple of dams here. You notice I put one little piece of wood here and one little piece of the wood here. This side here is already done, but after you have these two little sides of little pieces of wood on each side of the torque rod, you're going to make a third piece that actually looks like this, and you can see I cut a channel in it that's going to match the torque rod. All I did was just take a needle file and just sort of cut that into it. And then when that's done, you can go ahead and take that thing very carefully and stick it between these two pieces of wood right here, if I can get it in there. Let's see, there we go. It slides right down in there. Now the reason that you have to do this is when you mix epoxy, you want the epoxy to flow all the way down into this channel, okay, and wrap itself around that torque rod. And it's pretty fluid when you mix it, and you want it to go down in there. But the problem is it will actually flow all the way down the channel, or it could possibly flow all the way down the channel here, and it could lock the torque rod in place. Same thing on this side, it could flow out here and lock that in place and give you some problems. So by just creating a simple dam of scrap balsa wood here, a simple dam of scrap balsa wood here, that'll prevent almost all of it from flowing out of the side. Now we're ready to go ahead and fill this trench full of epoxy. What you want to have prepared in place and ready to go is a small piece of wax paper, because what we're going to do is epoxy won't stick to wax paper either. So we're going to fill this channel, and when we're done, we're going to go ahead and put that wax paper right over top. The epoxy is going to stick to it right away, and that's going to help sort of create a little bit of a suction and help keep the epoxy from moving down too far into the trench. And then when you're done, when you peel it away after it's dried, you're also going to have a nice clean finish, just like we did on the other side, where you can see here this is all nice and flat. Now even though it doesn't look beautiful, it doesn't really matter, because this whole thing is going to be inside the fuselage anyway. We're really just going for having a really nice tight bearing. Once you have all your epoxy mixed up, and you can use 30-minute or 15-minute, you could even use 5 if you think you're fast enough, but I would recommend stay with 30 or 15. I'm going to go ahead and use 15 on this one, because for the purposes of this video and getting it done quick. Go ahead and just start pouring it in there and let it sort of flow on its own all the way down in there. You don't want to fill the channel too fast because you want to make sure it gets all the way down into the bottom. So let gravity kind of do its thing. If you fill the whole thing up too much right away, it might sort of create like a big bubble down in there, which you don't want. So anyway, you go ahead and just let it sort of flow in there, and start at one end and just sort of push it around. This only takes a few seconds really to do, as you can see here. And if it's not going over there, which it's not flowing all that great, I'm just going to sort of push it down in there and let it sort of seep all the way down in there. If you have any extra sitting here, you can just kind of clean it off and push it into the center. But you only need a tiny bit of epoxy, but you do need enough that it's going to go all the way down in the channel. Anyway, just let gravity do its thing and let this thing flow down into where it's going to go. If you have too much, just scrape it off, just sort of squeegee it off there. And we should be good to go. It looks like it's in pretty good shape right now, so what I'm going to do is just go ahead and take the wax paper that I already had prepared, and I'm just going to very carefully lay it over. And as you see it go on there, you see it sticks to it. And what it does is it makes a nice flat covering over that. And what we're going to do is just leave it there and just let it dry. Don't touch the wing or anything. Leave it alone. It'll let it dry, and it'll give you a nice smooth finish. All right, after letting everything dry thoroughly, you should be able to just remove the wax paper pretty easy, and all you have to do is just sort of pull up on it, and you can see the wax paper doesn't really stick to it. Right here, I was starting to get a bubble, so as that happened, I actually put a little bit of epoxy here on top, just to sort of create a little vacuum so the bubble didn't become any bigger, because some of the epoxy was flowing down in there. But anyway, when you're done, guys, see how you can just pull this thing away, and it leaves a nice smooth finish, and again, the epoxy will not stick to the wax paper. So anyway, as you can see, you got a nice smooth surface there. Now all you have to do is just take a razor blade or a hobby knife, or you know, whatever you have, and just very carefully just sort of trim this balsa wood off, and it'll come off pretty darn easy. You can see how quick that was. You just go ahead and do that to the other side. If you have some extra epoxy on here, if it's only been drying for like an hour or so, you can just take some alcohol and just wipe this thing down, and it'll take off any extra epoxy that's sitting around. Now that we've trimmed away all the little wooden dams and everything's pretty cleaned up, all we have to do now is sort of break the contact that the epoxy has on the torque rod. And sometimes you hear a snap when you do it, but really all you gotta do is just very carefully just start to exercise this. You can actually see the lubricant in there and the rod as it starts to move. Sometimes it'll snap, but anyway, this one didn't. It's nice and fluid, and now we don't have really any play in there at all. Now you can just reconnect your linkage, and you're going to have a nice play-free aileron torque rod now. With the push rod reconnected to the top of the torque rod, you can now see that as you move the aileron, there's almost no play at all. You don't get that moving around anymore. Now, since it's still drying, we don't want to do it too much because the epoxy is still kind of soft, and we want to make sure that it does cure. But anyway, again, you can do this to elevators, rudders, and ailerons, anywhere where you have you know, a torque rod where it has lots of play in it. And usually when I do this kind of thing, I notice that the airplane flies much more precisely than it did before. When it comes to installing battery straps on the inside, I decided to place 2 battery straps in here. It looks like the battery is going to be placed right around in this area. And what I found was when I ran a strap here and I ran a strap here and tightened the battery down, it actually began to crack these thin side beams on here. So what I did was I took a small piece of wood, just light ply, and you can see I curve the edges so the battery strap doesn't bite into it. And the first one I took and I glued right in here, as you can see. So when I pull up on the battery strap, it actually, all the load is taken up by this piece of wood. The second piece is going to go right here. It's going to go underneath, and then the battery straps are going to go underneath, and they're going to be secured, and that'll wrap around the battery. Here's a look at the battery compartment and servo tray setup. You can see in here is a huge battery compartment in here. Power options and battery options are almost unlimited because you can put just about whatever you need to in here. Depending on the weight of the battery, you can shift it a little farther forward, a little farther aft to get the CG right. As you can see, I used some of this sticky shelf liner stuff. I just put some double-sided tape right along here and right along the center and just tacked it down. And this stuff keeps your battery from sliding around. 2 battery straps that I secured with some contact cement on the other side, so they just stick right on there and wrap around. You can see here, this is the battery wire that I'm using. I usually use Sky Lipos and Turnigy batteries, and they already come with the red connector, so I put those on most of my planes. This is the aileron connection that goes to the aileron. You can see here the Futaba receiver we have in there, and you can just tape your antenna to the side here, either with Scotch, or you can use some hinge tape, which is what I use, which is some 3M blender. Taking a look here at the servo setup here, I went ahead and I used a Z-bend, as you can see right here, instead of using a normal linkage. This way it won't slip. It just kind of makes things simplified there on the elevator. And the rudder setup, I used a much smaller horn than they showed in the instructions. I think that huge horn, you're just going to lose servo resolution and actually lose torque of the servo. So it doesn't need to be that big. So really about an inch, inch and a quarter is all you need there. And you can see the cables running there to the back. And you can see the steering linkage here I used with the easy connectors they provided. The easy connectors they gave you with the airplane are pretty good, so I went ahead and used those. Now on the other end of the rudder servo, I'm going to show you what I used back here. These are some linkages that I got from Hobby King. I had them sitting around, so I decided to use them in there, and you can see here it's about an inch, inch and a quarter from end to end. These just look like they would fit on there nice, and they seem to do a really good job keeping the rudder tight. If you don't have this kind of setup, really all you need to do is just drill a hole through here, get a length of 440 rod, and about an inch to an inch and a quarter, whatever length you're going to make this. Drill a hole, run that through there, and then go ahead and put a washer on each side and a nut on each side to back it up, and then you can go ahead and screw these little connectors down, and that's really all you need for that rudder connection. But for anybody that wants kind of a slick setup, wants to make it look really clean like this, those Hobby King linkages are not a bad way to go. One thing to note about the rudder cables on this airplane is that they're going to have to crisscross. And you can see from this video here, you can see the two cables that actually are run all the way back to the rudder connections that you can see right there. And when you set this thing up, you're going to have to make sure that the cable that's on this side, okay, actually runs over to the opposite side of the rudder. And this one here runs over to the opposite side. So your cables, when you wire them up, are actually going to crisscross like this back to the rudder connections. Now they may touch in the middle a little bit. If you don't set it up this way, what's going to happen is your nose gear is going to steer to the right, and your rudder is going to be steering the plane to the left. So by crisscrossing them, you get the rudder and the nose wheel turning to the right together and to the left together. Another area to note on the model is the elevator horn. This is what came with the kit, and I'm pretty sure that this was probably a mistake because this is kind of a hokey arrangement here. So anyway, I just got a Hayes style horn. You can use really any style of horn you want on there. Just make sure it's a tough one, a rugged one. I also used a Sullivan metal connector on the back here. As I flip this thing over, you can see there's a nice big plate on the back of this horn. So anyway, just make sure you use a tough horn for the elevator. Here's a quick look at the battery packs I've been using inside the Super Cessna, both 4,000 and 5,000 milliamp 4-cell packs. Really any 4-cell pack you have will fit inside this airplane, so you can really get away with using what you have. As you can see here, the battery compartment is both deep and wide, so it'll accommodate just about any battery pack that you have or want to get. And again, if you want to go 5 cells or 6 cells, plenty of space in here to accommodate anything. In fact, there's so much space, you can see I put my quantum telemetry unit in here, which for me has become a safety device, because honestly the only problem I'm having with this plane is that it's so much fun to fly that you tend to overfly it and sort of go into your battery a little too much. So the telemetry unit's been helping me out to kind of see how much amps I've been drawing. But anyway, guys, as you can see, plenty of space inside this battery compartment for any battery you might want to put in here. Here's a few extra features I added to my airplane that you don't have to do, but it's probably a good idea to do some of these. A spinner is optional. You can use the spinner nut that comes with the power package with the airplane if you want to, but I think a spinner just really looks good on this airplane. So this is an 1.25" Dubro. You can use any style that you want. I'm running a 1210 prop on here, And you can see the cooling holes I put in. It's probably a good idea to put cooling holes of some kind on there. You can make them bigger, you can make them smaller. I thought this was kind of Cessna-like, so I put 2 scoops in here, or intakes in here, so the air can come in, blow over the motor, which is right here, come down over the speed controller, and it can escape out this hole in the bottom. And it's pretty low profile, so the air can exit pretty quick. To get the rest of the air through the whole battery compartment, you can see the tail as we go back to the elevator here. There's a big hole back there, and the air goes through the fuselage pretty nicely. One more feature I added that I think is a real good idea. It's more of a safety device than anything else. But it's something I'll use every day I fly the airplane. And what this is a power disconnect. It's just a Dean's plug. I went ahead and glued one in there and soldered it in line between the motor and the battery. And you can see it plugs in there real easy. The reason for that is that this airplane was really designed back in the 80s to be a glow airplane. So for now, it doesn't really have a separate battery compartment like most electrics do today. So you turn your radio on and you plug in your battery, and now it's hot. So you go ahead and you put your wing back on, you tighten your wing bolts, and now you sort of have to go fly. You can't just get to the battery compartment, disconnect the wire real quick. It doesn't really have that built in. So I decided to put one in it. So now what you can do is you can just keep this plug disconnected. You can go ahead and plug in your battery and put your wing on, and now it's ready to fly. Except the power is just not connected. So you turn your radio on, and when you're ready to fly, you can go ahead and take your inline power switch here, and you can just plug that right in, and you'll get all your tones and everything. Now it's ready to go. And you can go fly. If you need to disconnect it for some reason, you can just pull it off. And that's the real reason for it. Let's say you see smoke, fire, something's going on with the airplane. Well, rather than, it's going to take you a while to grab a wrench and pull the wings off, pull the wing off. Now what you can do is you can just reach down here, grab this, and just disconnect the power quickly. So that was the real reason for designing that. It's not something you have to do, but I put it in there because I thought it was just a nice feature and a nice safety device for the airplane. Here's a quick look under the hood, or under the cowl, I should say. Everything went together nicely as the instruction manual said. One thing I've noticed about some of these prop drives that come with these planes is they're slick here. They don't have like a knurled end like some of the old glow motors did. And in order to get it to keep from spinning, you got to really, crank down on the nut that holds the prop and the spinner on there, and that tends to kind of damage the hub of the prop sometimes. So what I've been doing for a long time, what I do with this airplane, I made a double-sided sandpaper washer. It's just 2 pieces of sandpaper CA'd together, and this is the heavy-duty fibrous type stuff, not the paper sandpaper. So, but I put that on first, put my spinner, my prop on, and then I can tighten it to a normal amount, and that gives it the grittiness it needs to keep from sliding. So anyway, it works really nicely. This is also a stainless steel prop drive as well, so it's a pretty rugged one that comes with this motor. Wires run around here. I ran them right through here, connected them to the speed controller, and then put it underneath. This is the best place really to keep the cooling going, and as you saw from the holes in the cowling, it should come right in here over the speed controller and out the hole in the bottom. Fury speed controller, I just went ahead and mounted it here with Velcro. 2 strips on the block, 2 strips on the speed controller, and it stays on there pretty nicely. You got to center it pretty good because the cowling it's actually pretty wide, but you got to get it centered so it'll fit in there, and it fits on there with no problem. Positive wire I ran right down to here, and I soldered it onto this Dean's connector first. I soldered everything to this Dean's connector, and then I glued the Dean's connector on after everything was soldered. So, but you can see here the power connector is right there next to the nose gear block and this little block of wood that I actually fabricated and put in there. The other positive wire just runs right in here and goes into the battery terminal. Negative, same way. I had to put an extension on there, and it all runs into the battery compartment. One thing the speed controller has that some don't, and this one has which is a switch, and it runs all the way up here. I just turn the switch on, I leave it on, and I used a tie wrap to tie wrap it in place, so it doesn't get in the way, and it doesn't get switched off either. I made a couple mistakes drilling my holes initially for my cowling. I was trying to go into the firewall, but that ended up being too far back for the cowling. So I found that when you put it through here, it actually will go through the plywood sides, and it will actually go, and see here, here, and here, and it will actually go into, as you can see here, I'm going to zoom in here real fast, it'll actually go into the cowling compartment, as you can see from this hole right here. The other one you can see right here, it goes in there. So I found that to be the best location for those holes. And on top of that, it actually also gives you plenty of extra space. If you drill them any farther back into the fuselage, you're going to be right on the edge of the fiberglass cowl. So that gave me plenty of room. Anyway, guys, there's many configurations you can use to set your speed controller up and your motor. This is the setup that I used, and everything seems to be packed in there nicely. It cools well. It's real efficient, and it's neat and clean. A couple of additional items to note. We found when operating the airplane that our power switch worked absolutely perfectly, except that when you're out flying, it's easy to misplace this or drop it in the grass or something. So what we did was put a little rubber band on here, and when we're not using it, we just sort of lay it across there so it doesn't pop down into the center there. And then when we're ready to use it, we go ahead and just plug it in. Now, one thing we also did that I decided to put on here to keep it, to make it easier to put in, actually, depending on where you mount this thing, but you notice that I beveled the edge of the red plastic all the way around this thing. I also beveled the blades right here and right here on this side. And that just eases these things going into place. And sometimes you have to put them at an angle to get in. But if you just bevel that edge on your Dean's connector, if that's what you're using, this thing goes in much, much easier. Now, taking a look inside here, you can see how easy this thing attaches. I went ahead and I put a rubber band. It's a number 64, but you can use whatever you want. I attached it right here, looped it around, and then I looped it right around here, and it stays on there pretty nicely. And this whole arrangement has worked out quite well at the field. When it comes to programming your ESC, there's a lot of different logics to this. I really pretty much left mine almost stock, meaning that you don't have to do anything to this. You can just plug this right in and go fly. The only change I made to the speed controller with regards to programming it is I reduced the low voltage cutoff to ignore. And with this speed controller, you can program it to just, when it reaches about 3 volts or something, you can program it to either cut off power to the motor, reduce power to the motor, or ignore. Now, I usually set mine to the lowest possible setting, or ignore. A lot of guys try to save their batteries by having power get reduced to the motor or having the motor shut off. But then you often can end up crashing the entire airplane and destroying it and wrecking the battery sometimes by doing that. So if you fly too long and you end up cutting into the battery life, and you end up maybe puffing the battery a little bit, I'd rather do that than lose power to the entire motor and have the airplane go down and destroy the thing. So it's up to you how you want to program it, but that's usually how I set mine, and it's worked real well for me for years. Here's another look inside the fuselage compartment, and here's the slot where the front wing pin sticks in. And there is only one front pin, and it sticks inside this horizontal slot. And it's strong enough to handle flying, but this is the only little piece that kind of keeps the wing on right here. And it's a thinner light ply. So what I decided to do was take a thick piece of hard ply right here. And there's really not a lot of space to put something here, but I beveled the edge. And what I'm going to do is kind of glue that on here to act as a doubler. Now you notice I beveled the edge so the wing will fit in there just fine. And this should add quite a bit of extra support to that front pin. Here's a shot of the doubler glued into place. As you can see, there's not a whole lot of room in here. And again, you want to test fit this with the beveled edge on this before you glue it into place to make sure it'll fit. And this should add quite a bit of strength to the wing. In addition to strengthening the front wing pin mounting area, as we just saw, it seemed like a good idea to strengthen these rear wing bolts. Most wings like this have some sort of a plywood doubler of some kind that usually kind of covers this whole area, but there's just balsa here and there really wasn't one, and the little washers that they supplied were actually already starting to make a dent through this balsa, so you'll want to increase the size of this. If you feel like putting a whole plywood plate there, you can, but I felt just increasing the size of the washer would be enough. I use these fiberglass washers that I had sitting around. They seem to do a good job, but if you can find a larger fender washer to put there, really anything that you can do to increase the size of those will make the whole wing much, much stronger. Here's a final look at my completed Super Cessna. It's a real easy build, guys. All the items that you just saw there are everything that I like to do to my model, and everything is incorporated into this airplane and found to work perfectly. In fact, I'm actually shooting this video after all of the flying video has been done. So everything that you just saw in the video, which is really just suggestions only, we found to work really well on the airplane. You're free to build the plane exactly the way you'd like it, but feel confident that everything you just saw has been successfully and real thoroughly test flown on the airplane. Not only does this thing build well and fly well, but as you can tell from this video, it's just a really good looking airplane. Appreciate you guys watching the video. I hope you enjoy your Super Cessna as much as I do. Alright folks, that concludes this video on the Super Cessna from Shulman Aviation. Check it out at shulmanaviation.com. Once again guys, this thing will fly nicely and accepts any electric or glow power package that you want to put in this thing. As you saw in the video, it flies quite well with their recommended bolt-on setup, which is what I have on the airplane and what you saw in the video. And that consists of the Fury brushless motor, Fury ESC, and Futaba servos. And it is a real high-end setup. It bolts right on this thing, and it definitely is a really nice combination. Anyway guys, I'd like to thank you all again for watching this video. Check out this and other of my videos on YouTube. Check out rcinformer.com, and check us out on Facebook as well. I use Facebook quite a bit, and it's always a good place to go to send me a question or shoot a photo over to me if you ever need any help or any guidance with this or any of the other airplanes that I've done videos. Once again guys, thanks for watching, and as always, we'll see you next time.